Hello, thanks for joining me. We're going to run through a quick review for the final exam. And hopefully we'll just see a selection of the types of problems that you might see on the test. We'll start off with this one. This was the very beginning unit. What is the quotient? And for this one, if you remember, we did eventually learn synthetic division, but that doesn't work very well here because of that number in front of the x there, the 4x minus 1. That's going to make synthetic division difficult to do. So we will do long division. Set up our long division here. Inside we're going to put what we're dividing into, 8x squared minus 6x plus 1. Remember, we have to have a column for each of the exponents of x. So we've got an x squared, so there has to be an x to the first power column, which we have with the 6x, and the column with the x to the 0 power, which we have with that 1. We're dividing by 4x minus 1, and then we ask ourselves, how many times does 4x go into 8x squared? And that would be 2x times. So we put the 2x above the negative 6x because those are both x to the first powers. Okay, so 2x times 4x minus 1 is 8x squared minus 2x. So I took what I think how many times it goes in, and I multiply, and this is where this gets a little bit difficult to remember maybe. I don't know if this is very tricky. It's tricky. We're going to subtract. And what we're actually doing, we have to remember, is we're actually subtracting both the 8x squared and the negative 2x. So minus negative 2x is plus 2x. So we say we're subtracting, and then we kind of distribute the subtraction sign there. Alright, so let's get this done. If we subtract 8x squared from 8x squared, of course we get 0, and that's our goal here. We're just trying to get 0. We're trying to get that first term canceled out. And then negative 6x minus negative 2x. Minus negative is plus. Negative 6x plus 2x is negative 4x. Then we bring down the next term in the line, and we do it all over again. How many times does 4x go into negative 4x? Well, negative 1 time. And that negative 1 goes above the top line there, and right above the column where we have all our numbers without an x. Negative 1 times 4x is negative 4x, and negative 1 times negative 1 is positive 1. And so you can see that these are exactly the same. So when we subtract them, right, you subtract two things that are exactly the same, then you get 0. And so that's what we're going to do. We're going to subtract negative 4x minus negative 4x is 0, and 1 minus 1 is 0. So we get 0 here, which is always a very happy day for anyone who's doing long division, because that's our remainder. So you can see our remainder is 0. So the answer then is that 2x minus 1. And I just want to point out a couple of things we learn here. Remember that this is a big old long problem. 8x squared minus 6x plus 1 divided by 4x minus 1 equals, so the answer is the 2x minus 1. Now, that's the whole answer for this one. If there had been a remainder, it would have been plus that remainder, in this case 0, divided by 4x minus 1. So just remember that that's a possibility. It didn't happen in this one. And then we can answer the question, is 4x minus 1 a factor? And we say yes, it is a factor because it divides evenly, and what's left over is also a factor. So we could say that we have factored 8x squared minus 6x plus 1. So a lot of good stuff going on there. Moving on to a different section of the course. This is a logarithm. There's a lot of things to remember about logarithms. One of the main things is that logarithms have to do with exponents. So anytime you have a number and you can put it in exponential form, that's a really good thing to do. So I'm going to do that first with this 81. 81 is 9 times 9, right? So we could say 9 squared. But 9 is also something times something. It's 9, 3 times 3. So then 81 equals 3 to the 4th power. And that's what we're going to use. Okay, so the log base 3 of 81 is the same as the log base 3 of 3 to the 4th power. Now, we have a rule that says if you have a log base b of x to the y power, you can write that as y times the log base b of x. Okay, so that means that we can take this and write it as 4 times log base 3 of 3. Alright, that's helpful. And that's in our logarithm notes, so we've got logarithm notes somewhere. There's a whole bunch of laws of logs that we have written down. There's a second one. If you have the log base b of b, that equals 1. And that's because, remember that a logarithm, log base b of x equals y, is just a fancy way of saying b to the y power equals x. So if you think about it, if we have the log base b of b, then that would be equals something. Let's just question mark there. Then that would be like saying b to the what power equals b. Well, anything to the power of 1 equals itself, and so that's why the log base b of b equals 1. Or when the base of the log and what you're taking the log of are the same thing, then it just equals 1. So that allows us then to say that the log base 3 of 3 is 1. So this is 4 times 1, which is 4. And that's the answer. There was another way to do this if you wanted to. It's kind of calculator dependent. Log base 3 of 81 equals, and we would use this rule. One more rule I'll write down here. I've given you 3 rules. Let's write this one down. Okay, here's another one. Log base b of x equals the log base n of x divided by the log base n of b. Okay, so what that says is that if you've got a log and you've got a base, and any number can be the base of x, but we can transfer it into a different kind of log. Let's say a log that our calculator knows how to do, and by just doing the log of the whatever it is you're doing the log of divided by the log of the base. Okay, so what that means is that on the calculator we're going to type in log, and our calculator, when you type in log, it means base 10. So you don't have to say it, it just means that when the log button on your calculator means base 10. So log of 81 divided by the log, again it's base 10, of 3 equals, and then you do that on your calculator, and I'm not going to show you here, but if you get your scientific calculator out and do that, it's going to equal 4. It will. So there we go. Okay, so now we have another log type problem. This is a solving problem. Let's see. So, what's the best way to go about doing this? Oh, I know. We can use that rule that we just talked about. The log base b of x equals y can be written as, and I may be mixing up my x's and y's, and that's okay. Like if your notes have them on opposite positions, that's okay. It doesn't matter. Uh, those are just placeholders. So what matters is that it equals the b, whatever the b is, whatever the base is, raised to the power of the thing that the log equals. So y equals x. Okay, so that's the relationship that we want to recognize. Now, what this means is sometimes we have exponent and we can't figure out the exponent, and so we put it into logarithm form. Sometimes we have a logarithm we can't figure out, so we put it into exponent form. And that's what's going to happen here. So I'm going to transform this into the base x to the power of what the whole thing equals, -3, and say that equals what we're doing the log of, 125. Okay, now you may be saying, well, that didn't make anything any better, but you're right, but we'll see if we can get this transformed a little bit. 125 looks suspiciously like something that we could write as an exponent here. Let's type it in our calculator and see what we get. Okay, 125 divided by 5 is 25, and then divide 25 by 5 is 5 times 5. So 125 equals 5 cubed. 5 times 5 times 5. Okay, so we can write x to the -3 power equals 5 to the 3rd power. Well, that looks almost the same. And the idea here is that if we can get the exponents the same, then we can get the then we can say, well, then the bases also must be the same in this equation. The only thing that's different is that the x is to the -3rd power and the 5 is to the 3rd power. So what does that negative power do? Well, we know that if we have a number raised to a negative power, and my computer just went nuts, I don't know why. We'll erase that line. If we have a base raised let's try that again. I don't have a cough button here. If we have a base raised to a power, a negative power, let's say b to the -x power, that means that the negative part just simply means take that base and do the reciprocal, and if it's not a fraction, it's just a whole number, just put it over 1, or under 1, to that power. Or we could say the whole thing to that power. B to the power of anything is just, or 1 to the power of anything is just 1. So that's what we're going to use here. So the x to the -1/3 power means 1 over x to the 3rd power. But instead of doing it that way, I'm going to say let's turn that 5 to the 3rd power into a negative power. So all we have to do is take that 5 and write it as a fraction and then do the reciprocal. So x to the -3rd power equals 1/5 to the -3rd power. That negative power just means take that 1/5 and flip it over and make it into a 5 and raise it to the 3rd power. Okay, so now our bases, our exponents are the same, and since our exponents are the same, and these two expressions are equal, then the bases also must be the same. So x must equal 1/5. And that's how you do those ones. You remember doing those? Those are kind of fun, like a puzzle. Okay, now let's do the arithmetic sequence, and kind of as a cheat for myself, and I want you to do this as well. I have formulas written down. I've been kind of giving you some formulas to check and make sure that they're in your notes, but here's one that I wrote down for myself. The the iterative rule for the nth term of an arithmetic sequence with first term a1, common difference d, is an equals a1 plus n minus 1 times d. Now, we don't have, we're missing some stuff, right? We're missing d. We have a1 and we have, oh, and this is a mistake here. Let's do some quick calculating. I apologize. This is there's an error in my PowerPoint. Okay, I don't know if you caught that, but the error in my PowerPoint was the my second term here in my sequence. It's not the second term, it's the seventh term. I had mistakenly written as the first term again, so that wasn't very helpful. Okay, so let's make that the seventh term. So now we actually have three things here. We know what the first term is, a1, that's 5. We know what the seventh term is, a7, that's 35. And so n, when the formula says n, that just refers to the term number. N is going to be 7. So I'm going to do a7 equals a1 plus n minus 1 times d, and then notice that I'll have something to put in each of those spots except for the d spot. So we'll need to solve for d. a7 is 35. That's the seventh term. a1 is the first term, 5, plus n minus 1, that's n is 7, the seventh term minus 1, times d. So we have all that information, we put it all into the formula, and then we're just solving the equation. So we're going to subtract 5 from both sides, and we'll also do that 7 minus 1 is 6. So we get 30 equals, in the parentheses, 6 times d. Okay, then we're going to divide both sides by 6, and d equals 5. Now, this is a little bit confusing. The first term was 5. But the common difference is also 5, which just means that what we're adding each time is 5. So 5 plus 5 is 10, and the next term is 10, and then plus 5 is 15, and the third term would be 15, and so on. Now we need to write the formula. So the question says, what's the formula? And in order to know the formula, we had to know what the d is, that common difference. And I want to point out that it's just a coincidence that the common difference and the first term are the same. That's a complete coincidence that kind of makes this a bad question. That has we can't say that there's a rule that says that the first term, whatever that is what you put in for d. That's not true. So there's my first term in the formula. I'm writing out the a1, that's 5. Plus n minus 1, because for any kind of random term in this sequence, I don't know what n is until somebody says, oh, the 107th term or whatever. And then d is the 5, that's the common difference. And there's the formula. That formula then will tell me what any term in this arithmetic sequence is. I just have to say what term I'm looking for, what term number I'm looking for. Alright, moving on. I'm sure that's not the end of this. Oh, and my formulas aren't showing themselves here. Let's see if I can move this down a little bit. I think I can. There we go. Alright, so Jiao stacks soup cans in the shape of a pyramid. He has put 1 can on the top row, 2 cans in the second row, 3 cans in the third row, and so on. If there are 15 rows, what's the total number of soup cans? Now, obviously, Jiao didn't start at the top and work down like this, but you can kind of get the idea of how the stack is going. Is this an arithmetic or geometric? Well, in the first stack, there's 1, and then 2, then 3, then 4, so that makes it really easy. The common difference is 1, And the first row we're going to call A1 is 1. And then AN is going to be 1 plus n minus 1 times 1. Oh, and that's from the formula from the previous page, which we have down here. That's the iterative rule for a particular term. But that's not what's being asked of us here. We're not being asked what's the 15th row, which I think you can tell is 15 cans. But what we're being asked is what is the sum, or how many cans would be needed to make this tower of soup cans, as unwise as it may be. Well, that's a series question. Remember, a sequence is just a bunch of numbers in a row that follow a pattern. A series is taking those same numbers and adding them together. And so we have the formula down below. Sn equals n over 2 times a1 plus an. Okay, so we have a formula for an already developed here. I wrote it down for our soup cans. That would be we've got 15 rows, so A15 equals 1 plus 15 minus 1 times 1, which is 14 times 1 is 14, plus 1 is 15, so it's 15. So again, this is not a great example. There's just because of the simplicity of it. Okay, so A15 is 15, so we're looking for S, the series, 15. That just means the first 15 terms added together, and that's going to be n, which is 15, divided by 2, times A1, which is 1, plus an, or A15, which is 15. So filling everything in the formula, we've got 15 over 2 times 1 plus 15 is 16, so we'll say 16. We'll put it over 1 just to make it easier to multiply the fractions. We can multiply across, but we can also recognize that that 2 divides into the 16, so 16 divided by 2 is 8, 2 divided by 2 is 1. So 1 times 1 on the bottom, and 15 times 8 on the top, that would be 30 times 4, which is 120. 120. Now this is interesting to think about. We're talking about soup cans, so the number of soup cans has to be a whole number. It can't be like 100, it can't be like 120 thirds. So if we are doing a problem like this where the numbers are whole numbers, or are supposed to be whole numbers, talking about real things, then we know that we're off the rails if we get a fraction. But that's how we solve this problem, or apply the arithmetic series formula to this problem. Alright, how many ways can 5 family members be arranged in a row for a family portrait? So if you think about this, we've got a family portrait. We're going to put one person there, one person there, one person there, one person there, one person there. There's 5 people who could stand in this first spot. But once we've chosen that spot, then we have 4 people left to stand in the second spot. So there's 4 different ways those guys can stand. And there's 3 different ways for the third spot, 2 for the fourth spot, and then whoever's left over has to stand in the last spot, doesn't matter who it is. Now, that is a probability deal, and that's actually, we learned this, that's 5 factorial. That's what it means. And so we can do that. Let's see, 20, 60, 120, so it ends up being 120 ways. So there's 120 different ways that we could arrange this family of 5 for a portrait. Okay, now kind of going back into that theme of probability, Mindy pulls out 2 marbles from a marble bag. The bag contains 8 red marbles, 3 white marbles, 4 green marbles, 5 blue marbles. Find the probability that both the marbles are blue. Now, this is actually 2 events, right? Mindy is pulling out 2 marbles. One of them has to come out of the bag first. And so the idea then is if she takes out 2 marbles, of course one comes out first and one comes out second, but she's grabbing 2 kind of at the same time, which means she's not taking one, putting it back, and then taking another one. So the probability for the first event is going to be the number of blue marbles, and there's 5 of them, divided by the total number of marbles in the bag. So there's 8 plus 3 plus 4 plus 5. So whatever that is, 20. So there's a 5 out of 20 marble chance of getting a blue marble. But once she's done that, the probability for the second draw, she's drawing again, even though she's kind of doing both draws at once, kind of instantaneously, is, well, there's only going to be 19 marbles left after you take out the first marble. And there's only 4 marble. If we're successful the first time, there's only going to be 4 marbles the second time that are blue. So there we have it. And we can multiply across if we want to. 5 times 4 is 20. Oh look, there's a 20 in the denominator, so we can just reduce. 20 is 5 times 4. Those reduce down to 1 on top and then 19 on the bottom. Again, you can multiply across if you want to and then reduce your fraction. We can turn this into a decimal. I'm not going to here. You can just type it on your calculator if you want to, and that's perfectly fine. Just recognize if they give you the answer in fractions, you have to turn it back into a fraction. Okay, stem and leaf plot. Stem and leaf plot. I always get these mixed up with box and whisker plots, and I think you've probably seen me make that mistake before. I won't do it today. Try not to. So stem and leaf plot is where we have 2 columns, and the first column is going to be our tens column. And we're going to write all the tens. So we have 20, 19, 12, 33, 13, 24, 20, 13, 31, 11. Okay, so we have a 10, we have a 20s, and a 30s. And so I'm not going to write 10, 20, and 30. I'm just going to write 1, 2, and 3. That represents the tens place. And then I'm going to put in my numbers for the ones in over here is the ones place, and we don't have to write these little labels at the top. I'm just kind of showing you what's going on there. So the 27, I would write a 7 over here next to the 2. For 19, we put a 9 next to the 1. For 12, we put a 2 next to the 1. For the 33, we put a 3 next to the 3. For the 13, put a 3 there. And 24, let's see, put a 4 there. 20, put a 0. 31, put a 1 there, and then 11. And when you're doing this, I mean, you would maybe write it twice. I was trying to kind of get the number. You want to get the numbers in order. So now this is my pointer here. So this means 1, 1, that's 11. And then the 2 here means 1, 2, which is 12. And then the 3 means 1, 3, 13, and the 9 means 1, 9, 19. So we can see that there's 4 numbers in the tens group, and then there's 3 in the 20s, a 20, 24, and a 27, and then the 31 and 33. So we've got them all ordered here because I put these in order, and then we can do things like find the we're told to do things like that. Find the mean, median, and mode. Well, the median is the number in the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number in the middle of the 9 numbers, 1, 2, 3, 4, 1, 2, 3, 4, would be this one right here. The 5th number is the number right in the middle. That's 20. So we'll write that down. The median equals 20. The mode is the one that's used the most, and so we look on each row and see if there's a number that's more than once. Like if there were 2 11s, then there would be 2 1s in that first 10 row. But there are no repeats. There's no repeats at all, so there is no mode. because there's no number that's used the most. They're all used equally the same number of times, which is once. Okay, and then the mean. Now this was a little bit harder to do. The mean just means you add them all up, and then there's 9 of them, so you divide by 9. So we're just going to add them all up and divide by 9. I'm going to do some math magic here to get the mean, so that I can kind of do it without maybe pulling up my calculator and typing all this in. But you don't have to do this. So there's 4 10s, so I can say 4 times 10 is 40, plus the ones place, so 1 plus 2 plus 3 plus 9, that's 15, is 55. And there's 3 20s, so that's 60, plus the ones place is 11. If it was 0 plus 4 plus 7, so it's 71. And then there's 2 30s, which is also 60. 30 plus 30 is 60. Plus the ones place, 1 plus 3 is 4, so that's 64. So now I just added each of my rows up really easy, and then I can add up the sums of all the rows to get my total. So that's carry the 1, 12, 7, 9, I think that's 19. Is that right? Yeah, 19. Okay, so 190. So when I add them all up, I get 190, then I divide by 9. And so the mean is 190 over 9. And if I wanted to do that, kind of be a little bit more accurate, I can do long division, or I can do on my calculator. It's 21 1/9, which is approximately 21.1. It's actually 0.1 repeating, so we can round it off to 21 or 21.1, however we want to do that. So that's how you find the mean, median, and mode using the stem and leaf plot. Okay, Gina asks, every student in her son's class of 30, if they have ever had the chickenpox. 12 students have had the chickenpox. On the basis of the sample, how many of the 500 students in the school would Gina predict have had the chickenpox? So in the class, so we're going to have 2 ratios here, right? We're going to have the class ratio, and then we're going to have the whole school. And it's going to be a ratio of chickenpox, say CP, to the total number of students. So we have in the class 12 students who've had chickenpox out of 30, and we want to kind of extrapolate that to the whole school of 500 students. How many of them likely maybe had chickenpox? And so there we have it. That's the setup, that's the equation. We can reduce the fraction. I think you can see that 12 over 30 reduces to, let's see, we divide by 6, we get 2/5, 2 out of 5, which makes this really easy to see. Because if 2 out of every 5, then it would be 200 out of every 500. But we can cross multiply. 5x equals 1,000, and divide by 5. X equals 200, as we expected. So we would predict about 200 students in the school have had chickenpox if this sample ratio holds. Okay, which 2 diseases have similar percentages of incidence? How close are the 2 percentages? Let's change the pen to red. It's just reading a chart. So you can see here the first one, it's about 25%. And this one is either 30% or just under. We might say that's 29%. This one is really close to 50, but not quite there, so maybe 47%. And this one is not quite as close, so that might be 56%. And if you said that was 48 and 57, I wouldn't fault you on that. And then this last one is again kind of similarly close to the 20%, like the 60. That one before is close to the 60s. That I'm going to say that's 16%. So what we're supposed to ask is which ones of these are closest together. And so 25 to 29, I think fairly obvious that those are the closest. 25, 29, there's a difference of 4% there. Obviously 29 to 47, it's a vast difference. But 47 to 56, no matter how you estimate these, it's going to be a 9% difference between those two. And the 16 to 25, again, even if you said that was 17%, it would be an 8% difference, 8 or 9% between the 16 and the first one, which is 25. So that's always what you want to watch out for. That last one and that first one are so far apart visually that sometimes it's hard to remember that we can still compare them. But in this case, they're still not as close as the first two. The cancer and the lung are the two that are closest, and they are about 4% apart. I realize I'm going a little bit fast here. I hope that you are taking the opportunity when watching a recording to hit the pause button, try to do the problems yourself, go back and re-watch bits and pieces of it that you might need. Okay. Let's see if we get our pen working here. The equation of the circle. So remember, we have a formula, and we just did this. This is the last thing we did. It goes like this: x minus h squared plus y minus k squared equals r squared. R is the radius. So in this one, hk is the center. hk is the center, so that's negative 3, 2. So we're going to write x minus negative 3 squared plus y minus 2 squared equals, and then the radius, we'll need to count that. We can go in any direction. 1, 2, 3, 4. Looks like 4. We can verify it by counting in all 4 directions. We get 1, 2, 3, 4 spaces. So that's 4 squared. That's the thing that everybody forgets to do. 4 times 4. 4 squared is 16. And that's how the formula for this one will look. Okay, what's the next value in this sequence? Well, we need to determine what kind of sequence this is. Is this an arithmetic sequence or a geometric sequence? And so arithmetic sequences are so much kind of easier to handle that we try that first, even though I'm kind of thinking that's not going to work. But we'll take that second term, 13.5, and subtract the first one, 9. See if there's a common difference. So 13.5 minus 9 is 4.5. Okay, so far so good. Then we'll take the third number, 20.25, minus the second number, 13.5. See if there's a common difference there. And that one I get, looks like 6.75. It's definitely not 4.5. So the common difference, it's not an arithmetic sequence. Not arithmetic. Because there's no common difference. The spaces between the numbers are not equal. Okay, so then we're going to look to see if it's a geometric sequence. And a geometric sequence doesn't have a common difference. They have a common ratio, and we do the same thing, the same numbers, that is, but we do division instead of subtraction. And so I'm going to do 13.5 divided by 9, and then I'll do 20.25 divided by 13.5, and then I'll do 30.375 divided by 20.25. So just dividing each number by the number before it. Now I have to pull out my calculator and run this on my calculator real quick in order to know what the answer is, because I'm just not gonna do those ones long-handed. So 13.5 divided by 9 is 1.5. So that's promising. I don't know why I say that's promising, but it seems promising to me. And then 20.25 divided by 13.5 is 1.5 also. And then if I type in 30.375 divided by 20.25, I get 1.5 again. And so, hooray, success. All the ratios are the same, so the common ratio is 1.5. That means that to get from one number to the next, we multiplied by 1.5. Which allows me then to go to the next number, because that's just going to be 30.375 times 1.5, the common ratio. So type that in my calculator real quick. And I get 45.565. You can say that because I'm multiplying by an odd number by 1.5 each time, 1.5 is 1.5, that I'm getting a half, and then a half times a half is a quarter, and a half times a quarter is an eighth, and it just keeps getting a smaller and smaller fraction as part of the answer, along with the half of the whole number, 1.5 of the whole number. So the actual number gets bigger and bigger, but the decimal gets smaller and smaller there, so that's a little awkward. Alright, we are on the last one for this review. What's the equation of the parabola with a vertex, the origin, focus at 0, -5? Okay. So if the focus is at 0, -5, and the vertex is on the origin, so 0, -5 would be right here. If the vertex is right there, then there's going to be the directrix, we call it, the line right there, and the parabola is going to be opening down like this. So that's what it's going to look like. So in that case, the focus length would be, we'll say -5. And we need to use the formula that goes with a parabola that looks like that, and there it is down there in the notes there. Y minus k equals a times x minus h squared. And the thing that's missing here is that a equals 1 over 4 f. F is the focus. In this case, it's the -5. So let's figure that out real quickly. A equals 1 over 4 times -5, which is -20. So A equals -1 over 20, or -1/20. Alright, now the vertex, this is laughably easy, and the vertex is on the origin, so that's 0, 0. So my h and my k are zeros, so I just have y minus 0 equals a, which is -1 over 20, times x minus 0, which is just x, squared. So I didn't even have to write the parenthesis there if I didn't want to. I could take that out. And that's all there is to it. Okay, and that's the stuff that should be kind of freshest in your mind. Make sure you have all those notes available to you before you take the final exam. Thanks so much for watching. This is a long one, but hopefully it was helpful, and good luck.